Here we'll discuss predicates and quantifiers. So a lot of mathematical statements contain variables, like x is an odd number. And this isn't a proposition because the truth value depends on the value of the variable. So for instance, if x is 5, the statement is true, but if x is 4, the statement is false. So this makes this not a proposition. The truth value can be expressed as the function p of x. So a logical statement whose truth value is a function of one or more variables is called a predicate. So for our example before, p of 5 would be true and p of 4 would be false. And a predicate can depend on more than one variable. So for instance, q of xy can be defined as x squared equal to y. R of xyz can be defined as x plus y equal to z. The proposition 5q, 525 is true since 5 squared is equal to 25. The proposition R236 would be false, however, because 2 plus 3 is not equal to 6. The domain of the variable in a predicate is all possible values for the variable. This could be defined ahead of time, or it could be implied just to be the biggest possible set. So for example, a natural domain for the variable x and the predicate x is an odd number would be the set of integers, since this is really the only time an odd number makes sense. If the domain of a variable in a predicate is not clear from the context, it should be given. Maybe we don't want to consider all integers, maybe we only want to consider the positive odd numbers, in which case we would need to define that. Statements that occur outside the realm of math can also be predicates. For example, the city has a population of over 1 million. The city is the variable, and we'll define the domain to be the set of all cities in the United States. So when the city is New York, this becomes New York has a population of over 1 million, which is true. If we look at Toledo, we have the statement Toledo has a population of over 1 million, which is false. It may happen that a statement p of x is true for all values in the domain. However, if it contains a variable, it's still considered to be a predicate and not a proposition, even if it's always true. So for example, the statement x plus 1 is greater than 1, the domain is all positive integers. Then the statement is always true. It doesn't matter what value in the domain we use, it will always be true. However, p of x is still a predicate and not a proposition since it does contain a variable.